Hello everyone, welcome back to sisyaclass YouTube channel. So in today's session, we will talk about solid state. Okay. So we are going to cover another chapter from class 12, the very first chapter, in which you will learn about different types of crystal system. You will learn about different types of solids based on intermolecular forces of attraction, and you will find so many questions are asked based on that identification part only. Very simple, easy peasy kind of questions. Then we will understand about different types of crystal system, okay, and how do we compare the number of atoms per unit cell, number of tetrahedral, octahedral voids, and some other features of important unit cells. How do we understand their structure also? Sometimes they give you the structure in the question and they will ask you to identify it. Very simple. Okay, we have a lot of graphics also in today's class, so you can easily identify it. Okay, so before we start, let me give you one information about sisyaclass. Good afternoon, Harsha. Welcome. So we are going to start with our maths course for grade 3 to 10. It will start on May 5th, and the entire course for the year will cost you rupees 999. So if you calculate it per day, the cost is less than 3 rupees. Very cheap. And who is going to teach you? IIT, NIT teachers are going to teach you the entire course. Your CBSE, ICSE and state board syllabus will be covered there. You can scan this and download our app, and if you download our app and enroll in our course, then you can also take help of Sysya AI. Okay, so Sysya AI can help you in doubt solving, text to text out solving, speech to text out solving, and image to text out solving also. So many features are present with your Sysya AI. Okay, so this is all about our 1 year maths course for just rupees 999. Now let's begin with our session. Before we start, let me introduce myself. So we have done so many different sessions from the EAPCET series. I hope you are following them. I hope you have saw questions based on them, and it is helping you in your preparation also. So after the class, revise the content once again and solve some more questions, because all the important concepts we have already covered in the class itself. Okay, so after that, practicing question, that is your task. So my name is Nidhi, and I have done my post-graduation from IIT Bhubaneswar. I have over 6+ years of experience teaching JEE, NEET and other competitive examination. And in today's class, we are going to learn about solid state. Okay, so let's start everyone. How are we going to proceed in this session? If you are following, you already know we first discuss the content in which we cover all the important concepts that can be asked to you in the examination. Then we start with the questions, and while solving questions also, if we find something new is asked, we understand the concept first and then we solve the question, right? This is what we have done so far. Today also we will continue with it. All right, so what are the major topics we will discuss today? We are talking about solid state. Let's see. So first we will understand about the properties and types of solids. You will find it very simple. You already know most of the things, and how the questions will be asked. They will mention different compounds and they will ask you to identify that whether it is a covalent solid or a molecular solid or ionic solid or metallic solid. As simple as that. You just have to identify the type of solid based on intermolecular force of attraction which is present there, and you are done. Okay, next we will understand about the different types of crystal structure of solids. There are 7 crystal systems. Yes, you have to memorize it. You can skip on the examples part, but you should know the edge length relationship and the bond angle, because it is asked directly that what is the edge length relationship for this type of crystal system. Only 7 you have to remember, but yes, you have to memorize them. Okay, next we will understand about the cubic system and our Bragg's equation. We will solve some questions also on the basis of that, and we will obviously see the formula. Okay, and finally we will talk about the imperfections in solids. So how do we understand solids? That there is a perfect arrangement that is repeated after intervals, correct? But what we assume that solids are perfect, they are not perfect. There are chances that some impurities are present in your solids, that some of the cations are missing, that some of the anions are missing, or both of them are missing and electrons are present in the interstitial sites. So that will create some kind of anomaly, some kind of imperfection in solids. We have to learn about them also. We have to understand their features as well. Again, direct questions will be asked from there, and if you read it once, you will be able to remember the imperfections also. We will talk about line defect, point defect. Point defect is important for us, but you should know about line defect, at least the definition. Okay, so let's begin, everyone. Let's start with the first part. Properties and types of solids. Okay, so see, we have everything in a tabular form. Okay, so you can take a screenshot or you can write it down and then you can revise it, so that everything is in one single place in a tabular form. It is much easier to remember. Okay, so you already know about these things, so don't think that it is something extraordinary that we are learning here. You already know about these things from chemical bonding and molecular structure itself. Now we are specifically talking about solid state, so we are repeating those same things once again. Okay, so what are we talking about? Ionic solids. What are the constituent particles? Is it rocket science? If we are talking about ionic solids, obviously the constituent particles are ions, cations and anions. No need to memorize, we already know that. Okay, what type of force of attraction is present there? If there are cations and anions, there will be electrostatic force of attraction. Again, very simple, very easy to remember. Do we have to know the properties? You already know about them. You have learned this thing in chemical bonding and molecular structure, the very first session that we have seen. Okay, so they are hard, they are brittle. Why do they have high melting point? Because they have strong intermolecular forces of attraction. So very high temperature is required in order to break them. As simple as that. Okay, and they have ions present when you add them in solution. So they will conduct electricity also in aqueous solution. If you take them in their solid state, obviously they will not conduct electricity, because in solid state ions are not free to move about. But if you add them in solution, free ions are present and free ions will conduct electricity. Okay, so they are conductors in aqueous solution, not in solid state. Examples: NaCl, KCl, magnesium oxide. You can write plenty of examples here in which cations and anions are linked together by electrostatic force of attraction. Okay, next, covalent solids. We also call them as network solids. Okay, covalent solids or network solids. How are they linked together? By covalent bonds. It is in the name itself. What type of constituent particles are present here? Atoms. Okay, so atoms are bonded together by covalent bonds. They are also hard. They also have high melting point if you compare them with ionic solids, less than ionic solids. But in comparison to the other different types of solids that we will learn next, molecular solids, they have stronger intermolecular forces of attraction, so they will have high melting and boiling point. Okay, they are insulators or semiconductors. They will not conduct electricity, because in this case we have atoms, not ions. So free ions are not present. If you want to conduct electricity, some type of charges must be present in solution. Those charges were ions in case of ionic solids. In case of covalent or network solids, we don't have any such thing. So they are insulators, and max to max they can be semiconductors. Okay, so examples: diamond, silicon oxide, silicon carbide. These are examples of covalent solids. Okay, or network solids, you can call them either one of these things. In the question also they may write network solids. Don't get confused, what is this new thing? Covalent solids are also called as network solids. Okay, two more types. We have molecular solids. They have weakest intermolecular force of attraction, right? Weak van der Waals forces of attraction are present. Maybe sometimes you will see hydrogen bonding. If hydrogen is linked with oxygen, nitrogen or fluorine, there are chances. Otherwise you will find van der Waals forces of attraction are present there. Okay, so in this case, what are the constituent particles? Molecules. And forces of attraction, please see, van der Waals forces of attraction, and hydrogen bonding is a special case of these weak interactions. They are not present in each and every molecular solid, but if you find hydrogen is present along with a highly electronegative atom, oxygen, nitrogen or fluorine, hydrogen bonding is also possible, not always. Okay, so examples: ice, water, iodine, carbon dioxide in solid state, ammonia. Ammonia, water can also show hydrogen bonding. CO2, I2, no. CO2 and I2 will be linked by weak van der Waals forces of attraction. Don't say hydrogen bonding in that case. Okay, I'm going to write it. Hydrogen bonding. In ammonia also, you will see hydrogen bonding, not in iodine, not in CO2. There you have only weak van der Waals forces of attraction. Okay. Next, metallic solids. So, first of all, how do we understand metallic bond? We have learned this thing in chemical bonding. These are positive ions in a sea of free electrons. That is how you understand it. Okay. What type of bonds are present between them? Metallic bonds. Will they conduct electricity? Electrons are present, free ions are present. Obviously, they are conductors. Okay. See, they are good conductors of heat and electricity. So you don't have to memorize them per se. If you understand the type of force of attraction, you can write it yourselves also. And how they will ask you the question? They will ask you to match them. They will give you these solids, will ask you to identify that type based on intermolecular force of attraction. That is all you have to do. We will solve questions also on the basis of that. Okay. So this is all about the types of solid, type of force of attraction, type of constituent particles, and examples also. Let's move to the next part. See, different types of unit cells. So we have simple unit cell, simple cubic unit cell. What do we have to remember in this case? That your atoms are present only at the corners of the cube. Where are the atoms present? Only at the corners of the cube. Okay. What about body-centered cubic unit cell that we also write as BCC? Atoms are present at the corners. That part is same. But in addition to that, you have one atom present at the body center. Do we have to remember this information? Yes. In simple cubic unit cell, atoms are only present at the corners of the cube. In body-centered cubic unit cell, atoms are present at the corners of the cube. In addition to that, there is one atom present at the body center. What about face-centered unit cell? Sometimes it is written as CCP also. In the question, don't get confused. Cubic closed path structure is FCC only. So there are two names for this compound. Face-centered cubic unit cell and CCP. Cubic closed path unit cell. Okay. So in this case, where are your atoms present at the corners? That part is same. In addition to that, you will find there is one atom present at the center of each face. How many corners are there in a cube? You should know that also. You know that, but still. I have 8 corners in a cube. How many faces are there? 6. Edges. You will need this information when you will talk about the contribution of each and every atom. Okay. So in case of face-centered cubic unit cell, you have 8 atoms present at the corners. In addition to that, you have one atom at the center of each face. Okay. What about end-centered unit cell? In case of end-centered unit cell, you will have 8 atoms at the corner. Okay, great. Each and every unit cell has that. In addition to that, you will have 2 atoms present on the opposite faces. Any 2 opposite faces. 8 corner atoms. 2 So you have 8 atoms present at the corners. In addition to that, you have 2 atoms present on the opposite faces. Any 2 opposite faces, not all of them. That will make it face-centered. Okay. So this is your end-centered unit cell. Now we understand about these 4 unit cells. How will they ask you the question? What is the contribution of each atom present at the corners, present at the face center, present at the body center, and on the basis of that, how will you find number of atoms present per unit cell? Again, very important, they will ask you. So we have a table for contribution, and then we will see the number of atoms per unit cell that you should know about directly. Okay, so please see. So based on location, we are talking about those 4 unit cells that we have just now studied: simple cubic, end-centered cubic, body-centered cubic, and your face-centered cubic. Okay, SCC, BCC, FCC or CCP, and end-centered cubic, ECC. Okay, so in that, if you have an atom present at the corner, it will contribute only 1/8 to the unit cell. Rest everything will be shared with the surrounding neighboring unit cells. Only 1/8 will be the contribution at the corner. Please remember that. Okay. What about edge center? 1/4 contribution. What about face center? Half. What about body center? The entire atom is present within the unit cell. It will contribute completely to your unit cell. Why we are learning so much about the contribution? Because you have to identify how many number of atoms are present per unit cell. We have an entire table waiting for you, but you should know about the contribution first, because you have to solve questions based on it. We will learn about many such questions today. Okay, so this part is done. In addition to that, you have something called hexagonal close packed structure. Let's see that also. Not very common, but very different from these cubic unit cells that you have seen. Now we have a hexagonal unit cell. Let's talk about where are the atoms present there. Okay, so this is your hexagonal close packed structure or HCP unit cell. Great. So where are the atoms present here? First of all, it is a hexagon. Okay, so you have 12 corners in case of hexagon. Try to see it like this. This is one face. Imagine it in 3D. Okay, this is one face. This is another face. 2 hexagons. Correct? So on 12 corners of the hexagon, you have 12 atoms. Okay, so I will write it here. 12 atoms on the corners of the hexagon. Okay, then you have 2 atoms at the face center. And you have these 3 atoms which are shown in this red color. These 3 atoms are completely within your hexagonal unit cell. Okay, so 3 atoms at the body center. So if you want to calculate number of atoms per unit cell for hexagonal close packed structure, what will be your answer? Here the contribution of the corner atoms is different from a cube. In case of cube, the contribution was 1/8. Here the contribution is different. Here it is 1/6. Okay. So number of atoms per unit cell, if someone asks you about HCP, what will be your answer? 6. You have to remember this. And I have shown you how we come to this observation. Here the contribution at corners is different from a cube. Here it is 1/6. In case of cube, it was 1/8. What is the contribution at face center? Half in this case also. What is the contribution at body center? Still completely within the unit cell, completely contributing to the unit cell. Okay, so rest everything is same, only the corner contribution is different. Here it is 1/6. Please remember that. Okay, so how many atoms are present per unit cell? Your answer will be 6. And we have tabulated this entire thing. Now you will see that table. Please note it down, take a screenshot, up to you, but you have to remember that. Okay, see. Simple cubic unit cell, number of atoms per unit cell is 1. How we come to this observation? All the 8 atoms were present at the corners and the contribution at corner was 1/8. So that is how you get number of atoms per unit cell as 1. What about body centered cubic? We have 8 atoms at the corners and there was 1 atom at the body center. In this case, there were 8 atoms at the corners. 6 atoms at the face center. And what is the contribution at face center? 1/2. Hexagonal close packed, I have already solved it for you. These are the number of atoms per unit cell effectively. So maybe you see 8 atoms at the corners, but they are not entirely within the unit cell. They are shared with the neighboring unit cells also. We are talking about if we see one individual unit cell, how many atoms are present effectively, which are just shared by the unit cell we are considering, not by the neighbors. So this is what we mean by that. Okay. Then edge length in terms of radius, where are we going to use this information? When we calculate packing efficiency. Okay. So you have to remember this also. Then packing efficiency, in which case do you see the packing efficiency is maximum? What do you mean by packing efficiency? That you are talking about some solid, how the atoms are present with respect to each other. Are there empty spaces present? How much empty space is present? That will decrease the packing efficiency. But if your atoms are very close together, packing efficiency will increase. So in which case the packing efficiency is maximum? FCC and HCP both have 74% packing efficiency. You should know that directly. Minimum packing efficiency is present in simple cubic because atoms are only present at the corners. Rest everything is empty. Okay. In case of BCC, it is 68%. Okay. So now please do remember this entire thing, the contribution, the edge length, and obviously the packing efficiency. Okay. See the next part. Density of the unit cell, again you should know the formula because you will find direct questions from here. Okay, this is density. Number of atoms per unit cell, molar mass of the substance that you are talking about, that will be given in the question. So how many variables are there? I can see 5 variables are there. 4 variables will be given in the question. You just have to calculate one part. That is all you have to do. Substitute the values. Another thing in which they may confuse you is in the units. So they may give you the edge length in picometer, maybe in angstrom. They may ask you the answer in centimeter, maybe in meter. So you should know that there is a possibility of conversion of units. So please read the question very carefully. Okay. So you should know some common conversion factors. Okay. All right. So this part is done. We have learned about density of the unit cell also. Okay. Yes. Hi everyone. I hope you are noting everything down because we will solve questions also on the basis of that. Okay. See the next thing. Tetrahedral voids and octahedral voids are also present in your unit cells. Where are they present? You should know that. How do we identify how many tetrahedral and octahedral voids are present? You should know that also. Okay. So in which case the questions will be asked in case of FCC and HCB, and there's a simple way to remember it. Okay. Number of tetrahedral voids are twice of octahedral voids. You will use it for FCC and HCP. Note this down. Okay. How will we remember it? T20. Tetrahedral voids are twice of octahedral voids. I hope you can remember it. Alright. And how do we know number of octahedral voids? Number of octahedral voids you will find are equal to the number of atoms per unit cell. Okay. And based on that, you may write it as 2Z. What is Z here? Number of atoms per unit cell. And we will see so many different questions are asked from this particular formula itself. So you should know that. What we have done, first we have identified the number of octahedral voids. How many octahedral voids are present in any unit cell that is given to you? It is equal to the number of atoms per unit cell, that is Z. then how many tetrahedral voids are present in that unit cell? It will be twice of octahedral voids, and you are done. T20, like that you can remember. Okay. And one more thing, your tetrahedral voids are smaller and they are located at the edge centers. You should know their location. They can ask you this as a statement itself. Where are the tetrahedral voids present? On the edge centers. Where are the octahedral voids present? These are larger and they are located at the center of the unit cell and face centers. Okay, so like that you have to remember your octahedral voids and your tetrahedral voids. Now let's come to the next part. Bragg's equation. From here, direct question may be asked. N lambda 2d sine theta. Again, all the variables which can be asked from here, only one will be missing. Rest everything will be given in the question itself. You just have to substitute. Not at all fancy, very simple, direct question will be asked from you, but for that you have to remember the equation. That is your task, nothing else. Just remember the equation. Everything that you need for the substitution will be given in the question. You don't have to worry. Okay, so n is the order of the reflection, will be given in the question, don't worry. Okay, what is lambda wavelength of the X-rays? Maybe they will ask you to calculate it, or it will be given in the question. Great. Then this is the interplanar spacing between the crystal planes. So they may ask you to identify D, maybe lambda, and n theta will be given to you. So out of these two variables, one will be mentioned, other one will be asked. That is all you have to do. This is your Bragg's equation. Let's move to the next part. I told you about 7 types of crystal systems that you have to memorize. Please see the different types of crystal systems. You can skip on this part. You don't want to remember the examples, completely okay. You can remember it. Great, good for you. Otherwise, not that much important. But what you have to remember for sure, axial length and axial angles, they will be definitely asked. Okay, examples you can leave, but please remember the 7 crystal systems, and obviously the axial length and axial angles, they are sure asked directly. Okay, so you have your cubic system, most symmetrical. All the edge lengths are same, all the bond angles are same, and they are equal to 90 degree. Tetragonal, 2 of the edge lengths are same, third one is different, but bond angles are still same and equal to 90 degree. Then we have hexagonal crystal system, same thing, please notice, 2 same, third one different, 2 angles also same, and the third one is different. Leave the examples. They will not ask you examples fall apart that much frequently, but these 2 things for sure they will ask. Okay, next, rhombohedral or trigonal crystal system. All the edge lengths are same, but see, bond angles are different. Okay, so far we have covered, we have 3 more. Okay, we have total 7 crystal systems that they can ask us. Okay, see the rest of them. Orthorhombic, none of the edge lengths are same, but the bond angles are same and equal to 90 degree. Then we have monoclinic, none of the axial lengths are same, bond angles, 2 of them are 90 degree. Third one, we don't know. It is definitely not 90 degree. How much is it? We don't know. No one is concerned with it. That is how they will give you the question. So don't worry, what should be the angle? Should we remember it exactly? No. This is the entire information. It is not equal to 90 degree. It could be anything after that. Okay. Then triclinic, most unsymmetrical crystal system. Your cubic system was most symmetrical, right? All the axial lengths were same. All the axial angles were also same and equal to 90 degree. Please see. Cubic system symmetrical completely. All edge lengths are same, all the axial angles are exactly same and equal to 90 degree. Now we are talking about the unsymmetrical, most unsymmetrical system. Triclinic, none of the axial lengths are same, none of the bond angles are same. Okay, so that is how you will remember it. Triclinic, most unsymmetrical, axial lengths, axial angles, none of them are equal. All of them are different. Okay, so this is all about 7 crystal system. Please take a screenshot of the table and please memorize it. Direct questions will be asked from here. Okay, see the next thing. What are the different types of defects which are present in your solid system? And then we will solve some questions. So you can have vacancy defect, or you can also call it as Schottky defect. What type of defect? Schottky defect. So what happens in this defect? Some of the ions are missing from their normal sites, and in order to maintain the electrical neutrality, the missing cations are same as missing anions. Equal number of cations or anions are missing, so density decreases in this scenario. Okay, see, atoms missing from its normal site, both cations and anions. This is what we call as Schottky defect or vacancy defect. Then we have, okay, I will write it here. They have explained it here. Alright, Schottky defect, see, equal number of cations and anions are missing. Similarly, you can have interstitial defect or dislocation defect. Okay, they have explained it. Dislocation defect. So in this case, cation leaves its lattice site and moves to a new site, that is interstitial site. So this is an example of interstitial defect. You don't have to remember it separately. Even if you remember these two, more than enough. You have to know the exact effect. You want to know the definition, read it once. They will not ask you the definition. They are concerned with whether you know what is the difference between Schottky and Frenkel defect. You will say in Schottky defect, ions are missing. What type of ions? Both cations and anions. How many? Equal number of cations and anions are missing. What is the change in property of the unit cell because of Schottky defect? You will say density decreases. Okay, write it. Density decreases because of Schottky defect, because ions are missing, right? What happens in case of Frenkel defect? In case of Frenkel defect or dislocation defect, ions will leave their original site and will move to a new site. Are they leaving the solid? No. They're just occupying a different site within the solid. So will that change your density? No. So in case of Frenkel defect, density remains same. In case of Schottky defect, density decreases. Okay. So in this case, you will see density remains same. And they will ask you such a question. This is for Frenkel defect or dislocation defect. Okay, we have seen these defects. What else is there? You can have metal excess or metal deficiency defect. It is in the name itself. If you have extra number of metals, cations, you will call it as metal excess defect. If the number of cations are less than your anions, you will call it metal deficiency defect. Deficiency, something is present in lesser amount. Excess, something is present in extra amount. Name will tell you the type of defect. Okay, so we see metal excess defect, extra anion vacancy with electrons present in the interstitial site. What do we call such sites where electrons are present now? We call them as F centers, and because of F centers, you will see color in your compound. So wherever you see the term F centers mentioned, you will remember electrons are present in interstitial site. Second thing you will remember, it will give you the color to your compound. F centers, electrons trapped in interstitial sites, will be responsible for color. Okay. Next, extra cations in interstitial sites with electrons. So electrons are present in the interstitial site. In addition to that, your cations are also present. Okay. And in this case, cation is missing and the valency is balanced by some other cation. One example, you have, let's say, NaCl crystal, and you add some impurity here, strontium chloride. Okay, you understand sodium is present in +1 charge, strontium is present in 2+ charge. So Na positive was present in your lattice. In that lattice you have added some impurity. Impurity is strontium chloride. When strontium chloride comes, chloride are same, they will not do anything. Strontium will replace Na positive ions. Lattice was of Na positive ion. Now strontium will occupy its place. Not each and every Na plus ion will be replaced, some of them. Now you understand we have something which is electrically neutral. If you want to replace Sr2 positive, if you want to add Sr2 positive in place of Na positive, Sr2 positive will replace 2 Na positive ion because it has 2+ charge. 2 Na positive ions must be removed, but only one ion will come, so the other place will be left vacant. Metal deficiency defect, this is what we mean by it. Okay, cation is missing and valency is balanced by another cation having higher charge. This is one such example. Alright, now let's move to the questions. Now you have to answer first thing that we have learned in today's session, types of solids based on intermolecular forces of attraction. Please see the questions are also based on that only. Okay, so let's start. Silicon oxide, it is a covalent solid. Yes, it is an insulator. If you have free ions, then only it will conduct electricity, otherwise it is an insulator. We have to identify incorrect statement. So far it is looking correct. High melting point, this is fine. Magnesium oxide, ionic solid, everyone. Cations and anions are linked together by electrostatic force of attraction. Okay, so in this case, this is an ionic solid. It will conduct electricity and it will have high melting point, but the statement itself is false. This is what you have to identify. Rest everything is okay. Water ice, molecular solid, which are linked together by hydrogen bonding. This is also insulator. It has low melting point. Fine. Silver, metallic solid, conductor, has high melting point. The incorrect statement is option B. Why? Because magnesium oxide is an ionic solid, not covalent solid. Okay, and this will conduct electricity, not an insulator also. Okay, so option B is correct. Let's move to the next question. A solid compound is formed by atoms of A. Now we will use that contribution part. We will use that number of octahedral and tetrahedral voids part that I have told you. Please read the question. It is not difficult, very easy, but you have to read the question in steps. Okay, so let's begin. There is a solid compound which is formed by cation A and anion B. We don't know what is the exact formula. We have to determine that. Okay, so you have cations A, you have cations B also, and you have some anions oxygen. So the formula has these three different types of ions, A and B cations, oxygen, anion. Okay, we understand. What else? Atoms of oxygen form HCP lattice. The type of lattice will give you number of atoms per unit cell. Okay, so if it is HCP lattice, we have learned the number of atoms per unit cell are 6, and if they are telling us oxide ions are present at the lattice points, so number of oxide ions will be 6. One part is done. Now I have told you for HCP and FCC unit cell, the number of tetrahedral voids are twice of octahedral voids, and number of octahedral voids are equal to Z. We have done this already. I am repeating it. Okay, so I have told you number of octahedral voids are equal to number of atoms per unit cell, which is 6 in this case. Number of tetrahedral voids are equal to twice of octahedral voids or twice of Z, which is 12. Okay, so this you should know based on the type of lattice. They will not tell you that what is the value of Z. That is why we have learned that table. Okay, so this part is done. Now read the statement. Atoms of A occupy 25% of tetrahedral voids. How many total tetrahedral voids are present? 12. A occupies only 25% of 12. That is all they are saying, right? Simple. Maths. So number of A atoms you will write 25% of tetrahedral voids, that is 12. 12 by 4, that is 3. So number of A atoms 3. Number of oxide atoms, oxide ions 6. What about B? B occupies 50% of octahedral voids. Total octahedral voids 6. Only 50% are occupied. So only 3 sites are occupied. So number of B ions 6 by 2, that is 3. Now write the formula A3B3O6. If you simplify it, it will become AbO2. Now tell me, is this difficult? No, it was not difficult. What we have learnt in this question, many such questions are asked. First thing, how will you start? You will start from here. Okay, you will start from here. You will see the type of lattice first. Okay, so they told us it is HCP lattice. Based on the type of lattice, we will come to know what is the value of Z, the number of atoms per unit cell. So I read the question, I saw HCP lattice, I have written Z is equal to 6. This is the first part that you have to do. I will write the sequence. Done. Now based on Z, you will identify how many octahedral and tetrahedral voids are present. How can we do that? I have told you one formula. T20, tetrahedral voids are twice of octahedral voids, and octahedral voids are equal to Z for FCC and HCP unit cell. Please apply to FCC and HCP, not to each and every unit cell. Okay, so Z was 6, octahedral voids also come out to be 6, tetrahedral voids come out to be 12. Rest everything is in the question. How many tetrahedral, octahedral voids are occupied and by which atom? So you have just calculated that and you come to this formula AbO2. I hope it is making sense. Very important questions. Multiple different types can be given to you. They will change the number of octahedral voids percentage. They will change the number of sites of tetrahedral voids. In the next question, you just have to change the number. Your formula is in front of you. Okay, see the next question. Some substances are given below. You just have to identify the type of solid. Very simple question. Okay, so you have to identify the number of molecular solids and network solids are covalent. Okay, let's identify molecular solids. I will write here ionic, if they are present, metallic, and finally your covalent solids. Okay, so ionic, I don't see any, leave them. What about silver? Metallic, let's leave it. CO2, molecular. SiO2, covalent solid. Zinc sulfide, okay, ionic. SO2, again molecular. Aluminium nitride, covalent or network solid. HCl solid, molecular, and finally water. Okay, so this is your entire thing. So what should be the correct answer? The number of molecular solids are 4, number of covalent solids are 2. Option D. That was the entire question. Just identify the type of solids based on intermolecular forces of attraction. We have seen one table in the very beginning of the session. Based on that, you can easily answer this question. Okay, see the next question. An example for network solid or covalent solid is This is ionic, ionic, ionic. This is your covalent or network solid. Done. That was the entire question. Just identify the type of solid. You will get free marks. Okay. See the next question. Match the list 1 with 2. Again, you have to identify the type of solid. Metallic solid, copper. Ionic solid, NaCl obviously. Molecular solid, water in solid form. And covalent will be diamond. Okay, so match them. A with 4, B with 3, C with 2, and D with 1. A4, B3, C2, D1. Option A. And that is your entire question. So types of solids based on intermolecular forces of attraction. Please see the type of questions that they can ask you. Okay, let's move to the next question. If the length of the body diagonal of a FCC unit cell is x angstrom, for the body diagonal, the length is √3a. It is given to us as x, where a is your edge length. Now read the question. The distance between two octahedral voids in the cell in angstrom is. The distance between two octahedral voids you have to tell in terms of x. So what is the distance between two octahedral voids in terms of edge length that you should know about? Distance between two octahedral voids, a by √2. Okay, you have to answer this in terms of x. Okay, so value of a is x by √3. Substitute it. This is the answer. Option C. Okay, so this information you already know. Body diagonal √3a, face diagonal √2a. Write that also. Okay, this is the length of your face diagonal in terms of edge length. This is the length of your body diagonal in terms of edge length. You should know this. Alright, and based on that you have calculated the distance between two octahedral voids comes out to be x over √6. Okay, see the next question. What type of unit cell is given to you? You have learned about different types of unit cells in the beginning. Simple cubic, body centered cubic, face centered cubic, and now we have end centered cubic. You have 8 atoms at the corners and there are 2 atoms present at the opposite faces. So this is end centered unit cell. See, they are just asked you to identify the type of unit cell. They are not asking you to do anything else. Okay, see the next question. Out of 7 crystal systems, how many have face centered unit cells? Only 2. Only 2 unit cells, sorry, only 2 crystal systems which we have seen have face centered unit cells. Okay, and you have to remember those 7 crystal systems. I hope you have written them down. I hope you are practicing them. You will see one question definitely from there. Okay, see the next question. The number of network solids and ionic solids. Okay, again, network solids or covalent solids. Okay, so aluminium nitride, network solid. This is metallic. This is molecular. Ionic. Okay, we have to count ionic also, right? So this is ionic. Diamond, again, network. Magnesium oxide, ionic. Great. Zinc sulfide, ionic. This is molecular, not needed, leave it. Silver, metallic, not needed. Ionic, network. So I can see 4 ionic and 3 covalent on network. Okay, so 3, 4 must be our answer. Option B. You just have to identify the type of solid based on intermolecular force of attraction. We have seen one table in the very beginning based on which we can answer this. Okay, see the next question. The correct option for axial distances and axial angles for hexagonal crystal system, I told you they can ask you a question directly. So if you have learned that table, you can answer this. All right. So you have 2 axial lengths same, third one different, 2 bond angles same, and third one is 120. So option C, this correctly represents the hexagonal crystal system. Okay. All right. See the next question. The molecular formula of a crystalline solid is X3Y2. Okay, great. Atoms of Y form CCP lattice. So number of atoms of Y present 4. CCP is same as FCC, for which Z is 4. So number of Y atoms are 4. Atoms of X occupied, number of tetrahedral voids will be 8. Octahedral voids will be 4. Okay, you should write that based on the type of lattice. We are done. Atoms of X occupy 50% of octahedral voids. So number of octahedral voids 4, only 50% are occupied. So number of X atoms will be 2. Great. And occupy 50% of octahedral voids. In addition to that, some percentage of tetrahedral voids. We don't know how much. Okay. What is the percentage of unoccupied tetrahedral voids? Let's find out how many of them are occupied. So the formula is X3Y2. So they must have simplified it. If number of atoms are 4, here it is 2. So number of atoms of X must be 6. Out of which 2 are octahedral voids. So rest will be your tetrahedral voids. As simple as that. So how many tetrahedral voids must be occupied? 4. How many are total? 8. 4 are occupied, total 8. So 50% are occupied, 50% are left unoccupied. Correct answer is option C. That is how you can answer it. Alright. So I hope this is making sense to everyone. A compound is formed by atoms A, B and C. Atoms of C form HCP lattice. Write this. HCP lattice. Z is 6. So number of C atoms are 6. Octahedral voids are also 6. Tetrahedral voids are 12. Write everything. Okay. A occupy 50% of octahedral voids. So number of A atoms will be half of 6, only 3. Number of B atoms will be 2/3 of tetrahedral voids. 8. Write the formula. So A3, B8, C6. A3, B8, C6. So if you know the relationship between number of atoms per unit cell, number of octahedral voids, number of tetrahedral voids, you can solve any such question. I hope you understand which are, we are not doing anything new. We are just repeating the same thing based on the information given to us in the question. You don't have to worry about how will we know how many voids are occupied. They will tell you in the question. You just have to read it carefully. Okay. See the next question. The density direct formula. First write down the formula for density. You just have to substitute it. Right? So density is 7.6 gram per centimeter cube. Great. It crystallizes in cubic lattice with edge length is given to us as 290 picometer. Please convert this to centimeter, because density is given in centimeter. Don't substitute the value in picometer. Please do the unit conversion. Okay, next, what is the value of Z? We have to calculate. Great. M is given. And Avogadro's number is also given. So you will substitute all these variables. I told you there are 5 variables. 4 will be given to you, 5th one will be asked. So 5 variables, 4 are given, 5th one is asked. Substitute the value and calculate the value of Z. It must come out to be 2. So that is your task. Just substitute it. I have written the formula, rest everything is in the question. So such direct substitution based questions are also asked. If you know the formula, you can calculate the answer. Okay, see the next question. The diffraction pattern, again direct formula. Bragg's equation, right? I told you they will give you everything. See, n is given. You have to calculate the distance d. Theta is given. So sine 30 will be 1 by 2 or 0.5 also given. And what else is given? Wavelength. And you have to calculate it in centimeter. Please convert it. Again, substitute these values and you can calculate the value of t. So in these questions, everything is given. You just have to know the formula and do simple substitution. Okay. So this is your Bragg's equation and how you calculate it. Please solve for t. All right. Okay. So that is all for today, everyone. Let me see if you have any questions. Mr. Lucky, hello. Can you say some easy and high weightage chapter of chemistry that I have answered? Lucky, we have covered all the chapters. Okay, if you see our channel, we have covered all the chapters that will be asked in your EAPCET syllabus. Okay, we have covered all the important points and we have solved certain questions based on it. Okay, so don't leave any chapter. Start from the beginning. You can understand the concept, then solve some questions based on it. Don't leave the entire chapter. You have obviously studied that chapter in your board, so it is not new to you. Don't think I will not be able to complete it, let's leave it all together. Don't do it. Okay, so follow all these sessions that we have done. I think almost 17-18 sessions only for 1 hour. Okay, you will get the grasp of the concept, and after that just solve a few questions from your last 5 years, and that will be more than enough. But you have to practice, you have to revise once. Okay, so I hope that makes it clear. All right then, everyone, that is all for our session today. What we have learned today, we have talked about the types of solids. We have classified them based on intermolecular forces of attraction. We have seen the different types of unit cells. We have also seen, no, Bhavani, I don't know Telugu. We have also seen the different types of unit cells and where the atoms are present at the corners, on the face centers. You should know that. All right. We have learned about the edge length, okay, the packing efficiency, the contribution at different sites, and how many tetrahedral and octahedral voids are present. And based on that, how they will ask you the questions. We have solved so many of them, and you will find multiple such questions in your examination. If you follow one single concept, you can solve any one of them. I hope we can do that based on the examples we have covered in the class. After that, you have to practice also, obviously, but the concept will remain same. Okay, we have learned about density, we have learned about Bragg's equation, and also about the defects in solids, and we have seen their characteristics also. Okay, so all the important points we have covered. We have solved questions also on the basis of that. I hope it is clear, and if you still have doubt, you can ask us in the comment box, and the PDF for this entire thing will be available on our Telegram channel. Okay, so you can see it from there and you can solve more questions from the PDF also. Okay, so that is all from my side. One more thing I want to tell you, and then we will end the session. So I just want to remind you about our maths 1-year program. If you have your brothers and sisters who are studying in grade 3 to 10, they can enroll in this course. All IIT and IT teachers will be teaching you, and the course is for 1 year in just ₹999. Okay, for the entire year, the entire syllabus, CBSE, ICSE, your state board syllabus will be covered in just ₹999. And you can scan this, download our app, and take help from Sisya AI also. You can ask your doubts there. The course will start from 5th May. So please join. Okay, so that is all from my side. I hope you understood everything. Please solve questions after the session, and all the very best for your examination. I hope you score good, and keep practicing questions, keep revising. Don't get disheartened. You still have time. Okay, bye everyone. Have a great day. Thank you so much for joining the session.